Okay, guys. On Friday, and Thursday for that matter, we were working with these exponential functions, right? On the front side, we are graphing them, that y equals a times b to the x. And then we talked about whether a situation was growth or decay, yes? And then the top of the notes on the back side, we did two problems where we were investing money in a savings account, correct?
Yeah.
Okay, so that's kind of recap of where we are at. Now, you should have the first two examples done up above this, right? If not, get with me or a neighbor after class or after I finish these notes, and we'll go from there. We're looking at the third example down. Suppose you invest $1,000 in a savings account that pays 5% interest. If you make no additional deposits or withdrawals, how many years will it take for the account to grow to at least $1,500? Okay, so let's go back. Let's dissect this and figure out some information. You have your formula at the top of your page, yes? Can't really do that very easily on the BenQ, but so suppose you invest $1,000 in a savings account. What do we know right now?
Our initial value.
Okay, our initial value, which initial value of $1,000 is our little a, if you will, right? In the formula, it's our little a. That pays 5% interest. What about that 5% interest? That's an R value, isn't it? And what do we specifically use for R? The decimal. So what is 5% as a decimal?
0.
Okay. 0.05. Okay, good. If you make no additional deposits or withdrawals, how many years? What are they asking? They're asking us to find how many years? What's that going to be represented by? T. They're asking me to find T. So how many years will it take for the account to grow to at least 1,500? What is that 1,500 then?
Our answer.
Okay. It's normally our answer, yes. It's our answer after so many years. How about if I say it is A of T? Okay, that's our A of T, which that's why this problem is different because, and I guess I should have highlighted this as at least 1,500. We're used to finding A of T, aren't we? Here, they're giving us A of T. So we're going to fill in that formula, and we're going to talk about how we have to proceed. Our formula is A of T equals A times 1 plus R raised to the power of T. That's the formula from the top of the page. I just copied it down, right? So if we fill this in, what goes in for A of T?
That's true.
I was just thinking that. Okay, so 1,500 goes in for A of T. What about little a? What goes in for little a? 1,000. Times 1 plus R, which is 0.05, raised to the power of T. Okay, guys. My job is to find T here. Now, there's one piece of cleanup we could do right now. And what cleanup is that? In those parentheses, 1 plus 0.05 is 1.05. And our question is, when does that equal, or when is that, what was the wording? At least 1,500. Well, here's the deal. Do we know how, at this point in our math lives, how to solve an equation for t when t is the exponent? We do not. Now, give me a couple of lessons later on towards the end of the chapter. We'll talk about methods to solve. But right now, we don't. So I see some calculators working. What are you guys doing on the calculators?
Like plugging in random numbers.
Plugging in random numbers, yes?
Like you go like big intervals.
Okay, so kind of a guess and check type thing. And to be honest, that's the method I have for you guys at this point in our lives. Okay? In another week, I'll give you a more definite method. But for right now, we kind of have just kind of a guess and check setup. So here's what I'm going to do. I'm going to set up kind of a chart here so we can organize our guesses. My chart, I'm going to make a horizontal chart. I have T on top, A of T on bottom. Now, there was a gap because we did this on Friday. But go back up to the first example we did on at the top of this page on Friday. What do you notice?
It's the same.
It was the same pieces, right? $1,000, 5%, and what do we have right there?
9,300.
Yeah, at 6 years, it was $1,340.10. So, do we need to even start with any guesses below 6? No.
Let's try that.
That's my point, is you don't need to start down at 1. You know, be smart, use what we call educated guesses, right? So, did you try 7? I don't know, does anyone have it written down? What's 7 give you?
1,407.10.
$1,407.10. Now, I better pause for a moment. Do we know how she got that $1,407.10? Is everybody on that same page with me? Some of you are going to say yes. I see some head shaking.
She waited 7 years.
Oh, wait, you guys didn't even get to see the joke today, did you? Remind me, we'll come back to that. Now I just lost my screen in the process. Okay, so what I'm doing is I'm taking this right here, 1,000 times 1.05, 1,000 times 1.05 raised to the 7. Gives us the 1,407 and 10. It didn't work, right? Does that give it as big as I need?
No.
No, I'm looking for at least 1,500. So now what?
8.
Plug in 8, right? Or if you want to try jumping, you can. Just be careful.
Let's jump to 9.
Now, just with this in mind, guys, you can retype the whole thing. On this calculator, if I arrow up right now, it takes me back up to that line of math, and I can just go over to the 7 and type an 8 over it. It doesn't save you a whole bunch of typing, but it doesn't. It saves some. Okay, so at 8, $1,477.46 is what I wrote down, officially. Honestly, at this point, does it matter whether we say 45 or 46 cents? No. Okay, am I there yet?
No.
No? Okay, so try 9. At 9, $1,551.33. Okay. What's the answer to my question? 9 years? Are you confident it's 9 years?
Yeah.
Yeah, and this is, I know you wanted me to jump to 9 earlier. In all honesty, once I jumped, if I would have jumped to 9, you know what I would have felt like I had to do, though? I would have had to backtrack to 8 and make sure that 9 truly is the first one that takes me over 1,500.
That's right.
Okay? So I would not have, once I find one that's over 1,500, I want to backtrack and make sure that the one before it was not over 1,500. So how many years will it take for the account to grow to at least 1,500?
9.
And my answer is 9 years. Okay. Now, that chart's not a horrible, difficult thing to do. Okay. Be smart about it. And this is where you have to, I keep saying you have to have a calculator in this lesson, or in this chapter, right? Definitely have to use a calculator. Okay. Should we try the next one, or should we skip the next one?
We get like 2 minutes to try by yourself.
Okay. I'll start writing stuff out. You guys go ahead and start the next one. I'm going to write my formula, which I know, same as earlier. Are we headed in the right direction? Are we trying it? Okay, guys. I filled in some information. Have you made any progress? 500 was my initial, so that's my little a, right? 3.5%, so I made it 0.035. When I add that to 1, it's 1.035. Raised to the power of t. We want to know when this is at least $650. Where did you start on this one?
5.
I've heard 2, 5, 6.
I started at 1.
At 1.
I did 1.
I'll be honest, in my notes I have 1. Okay.
I just
Yeah,
tried
try
5
0
because,
years first.
see, I
Okay.
tried 5 because it's between 1 and 10, and I started like halfway.
Okay. And, you know, obviously, like, had Alexa start at 5 and she was already past 650, she'd know she'd have to backtrack. Do you have to try every single number? No. Okay. You pick some numbers that work for you. But once you get past that point, make sure you check the number directly below it. Okay. Okay, so our question is, when do we hit 650? If you started as low as 1, nothing wrong with that. What'd you get at 1?
517.
Okay. 517.50. Well, where are we trying to get? 650. Did you go straight to 2 or did you start jumping at this point?
Jump to 6.
Okay. I feel like 6 is a big jump at that point, but
It's worth it.
jump to 7? Okay. And again, you can backtrack if necessary, right? What if, let's see, I'm not going to write these all down because I don't have room more than anything else. I'm going to jump to 5. What'd you guys get at 5?
593 and 8%.
593, 84. We made good progress if you jump to 5, but are we there? No. Okay, so that, that was kind of a jump there.
I say jump to 7.
I say if we jump to 7, I don't want to do too big of a jump because I'm only trying to get to 650. At 7, I'm at what?
636.14.
That was almost too big of a jump, wasn't it? 636.14.
You still got like 20 more. That's more than that.
Okay. If we go to 8 next,
658.46.
658 and 40. And what do we know?
8 years.
8 years, yes? Okay, that is the one that took me above 650. And do I need to enter this on the calculator? Are you guys good with this? 500 times 1.035 raised to the 8th. There's my verification of the 658.40. By all means, ask during work time if you're struggling with the calculator. Let me help you figure out your calculator, okay? Even if it's not the same one I use, I can help you get it figured out. By the way, we have enough, right? Yeah. Still plenty of calculators in. Okay. One more type before I release you. Example 4, we're being asked to write an exponential function. And then we're actually going to have to solve it, or use it. So, the population of a given species decreases by 20% per year. If the initial population is 150, how many of the species exist after 11 years? Okay, so here's what I'm going to say. Forget the second part of this for right now. That's a separate question. I want to start with the first part here. I want to talk about how we can write an exponential function for this. And I was an exponential function that works for any amount of population. Okay, or I guess I should have not put my parentheses quite right there. Just realized that. Because in terms of given information, we're going to need the initial population. We'll answer that specific question in a moment. That's where I needed to put my parentheses, sorry. So if we're going to write an exponential function, you know the form we've been using, right? A of t equals little a times 1 plus r to the t. So okay, sorry, struggle. What information are we given?
Initial value.
The initial value. The initial value is 150, so that's going to be little a. What else? Your rate. What's my rate? 20%, which means I'm going to use 0.20. When I move that decimal 2 left, I'm going to use 0.20.
I think so.
Are we okay with that? What's a keyword in here that we also need to pinpoint?
Decreases.
Decreases. What's decreases mean? We're actually going to be subtracting, aren't we?
You subtract the 1 from the bottom.
Yeah, you're going to do 1 minus your percentage. Is that what you were struggling with? You didn't like the fact that I said it was just 0.2?
Yeah.
Okay.
No, I was like, you'd subtract.
Yeah. Okay. So if we write an equation that represents the situation, in other words, we're not going to worry about how many species exist after 11 years, but just a generic equation, because this is a skill that's important. So A of t equals A, which is 150.
Times 1 minus.
For 1 plus r, I'm going to say 1 minus 0.20. And then if this is just a generic equation that will work for any amount of years, we're going to say raised to the power of t. And so when I clean this up, if you just have to write the equation, I'm going to clean it up and write it as a of t equals 150. What is 1 minus 0.2? 0.8 raised to the t. So, and just a general equation that will represent this situation for any amount of years is 150 times 0.8 raised to the t. Now, this is one way to write it. I'm going to say or. The other option is, instead of using t and a of t, we could use x and y. And so you might also see it written as y equals 150 times 0.8 raised to the power of x. I use the t and a of t because that's what we were using. That's what the setup in the equation up above was, right? But this would be another way to write it, using x and y. So that was just kind of a little bit of practice there of writing an equation, an exponential equation, to represent a situation. How do I answer the question? Plug what in for t? 11. How many of these species exist after 11 years? So at that point, you're putting 11 in for either t or x, depending on which way you want to do this, right? And so if you want, you can just say, okay, it's 150 times 0.8 raised to the 11th. And your calculator is going to do the math for you, right?
I got a decimal answer. I think that's right.
I did too. It's right.
Well, we have some halves of animals.
Well, keep in mind, this is okay, so a little bugged by the decimal answer. I get it. But this is where, when I write down that the calculator gives me 12.88490189, realize it's decreasing by 20%, right? This is, just generally speaking, it's an estimate. What kind of answer are you going to give? Are you going to tell me that there are approximately 12.8849 of this species left? No. You're going to round, and we could look at this two different ways. We could say, well, we're not going to talk parts of, animals, so we're going to round down to 12. Or, again, it's just an estimate. And so, yeah, in my notes, I have it as approximately 13. Okay? So approximately 13 exist after 11 years. Again, it's an estimation.
On the test,
I would probably say
I guess it depends on the circumstances.
it does kind of depend on the circumstances.
if we have
Based on the fact that, like this one was 12.88, it was almost 13, it's okay to go up. So, okay, you guys know lesson 7.1 in Math Excel. So go ahead, get the iPads out, and let's make sure we can get the homework done.